Welcome to the vertical motion lesson of Unit 9. Now we're not just going to be dropping objects, we're going to be throwing the objects through the air. If you remember from the dropping lesson, we're going to use the same formula for the height after t seconds. H of t, or the height after t seconds, is equal to negative 1/2 times g t squared plus v times t plus s. Now for this section, we're going to be assuming that the gravitational pull g is going to be 32 feet per second squared, and that velocity could be anything. Now in the dropping lesson, what was velocity? Velocity that I added to the object was always 0 feet per second when I am dropping the object. For example, in the first story problem in your note packet today, we're going to be dropping the mic, but we'll get to that in just a minute. So just a reminder, h of t in your notes, you should type that h of t, or write that h of t is the end height or position after t seconds, and that's going to be measured in feet usually. Feet or meters or distance, etc. Because height is what we're measuring, or position, so there should be a distance unit there. T is going to be time. Time is usually measured in seconds in this class, or maybe hours, minutes. Any unit of time is going to be what those units are going to be. Alright, S is going to be the starting or initial position. A lot of people get the T mixed up with the S because they think that S stands for seconds, but S is actually the starting point, and V, of course, is the velocity. So let's say that you're given the end height. Let's say that you're given that the end height after a certain amount of seconds is 2 feet. And you're given that the original position or starting position was 30 feet and the velocity was 64 feet per second. And what I want to find is a time t. So let's start with our formula. And the h of t, or height after t seconds, the ending height, is going to be negative 1/2, and the gravitational pull on this unit is going to be 32 feet per second squared times t squared, plus the velocity after t seconds, that's a t, not a plus sign, plus the starting height. So we're going to plug in what we know. The end height is going to go in where? Where is the end height going to go? End height is going to go in for h of t. At the very end, after t seconds, I'm at 2 feet. Okay? Negative 1/2 of 32 is negative 16. What's going to go in for t? I don't know. That's what I'm trying to solve for. T squared. What's going to go in for the v? Well, the v is the velocity, and they give us the velocity. It's 64 feet per second. I'm going to put 64 in for the velocity. Still don't know what t is, so that's going to remain a t, plus the starting height. What's the starting height? Well, starting height was 30 feet. It tells us right at the beginning. So now I have this equation, which is 2 equals negative 16 t squared plus 64t plus 30. Now I can't really do anything in this unit until I have something set equal to 0. So what I'm going to do now is I'm going to subtract 2 from both sides. I'll have something set equal to 0. So I have 0 equals negative 16 t squared plus 64t plus 28. Now what I want to do is I want to solve for t. I want to know what t is when this thing is set equal to 0, and we could use the quadratic formula. And I'm going to write the formula down, but I'm going to do most of the math off the camera just because it takes so much time. But let's remember the formula to find out what t. Now, normally it's x equals for the quadratic formula, but now it's going to be t equals, and the song goes like this, remember? T equals negative v plus or minus the square root of b squared minus 4ac all over 2a. So we have to identify what the a, b, and c are now, because we're at this point here. So remember, they're the coefficients of the terms in the quadratic. So a is going to be negative 16, b is going to be positive 64, c is going to be positive 28, and I just plug in using framework, just like I've done in class a bunch. So instead of putting a b, I'm going to put a parentheses for where the b is going to go. Again, I'm going to do that inside for the discriminant as well, b squared minus 4 times a times c. We'll be able to tell right away how many solutions there are after I plug in my numbers. So the a value is going to be negative 16, so I'll plug negative 16 for the a's. Don't forget the negative sign. The b value is going to be that 64, so 64 and then 64 squared. And then the c value is going to be that 28 here. Now I'm going to do the camera or the calculations off screen, and I'll just do it step by step. Here's the first one. I want to simplify inside the square root. Now you can see that I've squared 64 over here and got 4,096. I multiplied negative 4 times negative 16 to get positive 64. And I did 64 times 28 to get 1792. Now 1792 is what I got here, so I'll just highlight so you can see where these numbers actually go. So that part here is this 1792, and then this 4096 is from the 64 squared. And I add them together and get this 5,888. Now at this point in the game, I've simplified the discriminant. I know there should be two real answers, and one of them is going to be negative 64 plus the square root of 5,888 over negative 32, and the other answer, t, equals negative 64 plus, or sorry, minus the square root of 5,888. Okay, all over negative 32. And then I'm going to use my calculator to figure this out, and you could just do that here. So I'll show you. I'll just clear this out. 5,888, take the square root, and I'm going to add 56, I'm sorry, not 56, what is it? Negative 64, so I'm going to subtract 64, I'll make it negative, and I get 12.73 repeating, and so other things, and I have to divide by negative 32, so I'm going to divide that by 32, and I'll make it negative. Looks like one of my answers is 0.3979, so I'm going to round to the nearest hundredth, which is this spot, right, the 9, and what comes after the 9, 7, so I round up. It's going to be approximately negative 0.40, or the other version, I have to take that negative 64, and I'm going to subtract the square root of 5,888. Okay, and that's, I get that number here, that negative 147,333, and now I'm going to divide that by the negative 32. I get my answer of 4.397 or 4.40. So t is about 4.40 or negative 0.40. Now what am I measuring here? That's time in seconds. So in that case, these are going to be seconds. But you could see right away that one of the answers doesn't make sense. Which answer does not make sense? Negative 0.40 seconds or 4.40 seconds? Well, obviously you can't have negative time, so the negative 0.40 does not make sense. So your answer is after about 4.40 seconds is where I reach that ending height. Let's say that after a concert, a musical artist decides to drop the mic, literally. If the person drops the mic from a height of 5 feet, how long will it take for the mic to hit the ground? Let's identify some of the things we want to plug into the equation. What is the ending height? If it's on the ground, what's the ending height? If I hit the ground, ending height will be 0 feet. That's what I'm going to plug into this equation for h of t. Okay, what's going to go in for the velocity? I think I used purple last time. What's going to go in for the velocity? If he's dropping the item here, I don't know why this is, there we go. If I'm dropping the item, oops, I don't know why it's been doing that lately. If I drop the item, what's my velocity? If I'm just dropping it, did I push or throw or do anything? The velocity is 0 feet per second in this example because I'm just dropping the mic. So that's your clue that if you're dropping something, the v sub 0 should be 0. Okay, so the v should be 0. Do I have a starting height? What's my starting height? Where did I start out? 5 feet. S is 5. G we already know is going to be that negative 32. So let's go ahead and plug in what we know into this equation. So for h of t, I want 0 equals negative 1/2 times 32 is negative 16 times t squared plus, and I should have said below, I want to find out what t is. So negative 16 t squared plus 0, oops, 0 is my velocity, so I'm going to have a 0 here, 0 times t, plus the starting height of 5. So now I have 0 equals negative 16 t squared plus 5. Now if I don't have a middle term, if I'm just dropping, what I can do is I can just try to solve by taking the square root. So I'm going to subtract 5 from both sides. Now I'm going to have negative 5 equals negative 16 times t squared. Then I'm going to divide both sides by that negative 16. And I get 5 over a positive 16 is equal to t squared. Now when I take the square root myself and attempt to solve for a variable, that means I'm going to have two answers, positive or negative square root. So I'm going to have t equals plus or minus the square root of 5 over 16. And you'll remember from Unit 6 that if I have a square root over a fraction, I can have the square root over the numerator over the square root of the denominator. Again, a plus or minus. Now this is nice because the denominator is actually a nice perfect square of 16. So the denominator will just turn into 4. But again, I have plus or minus the square root of 5 over 4. Now, which answer are you going to choose? Since I'm measuring time, does it make sense to have negative square root of 5 over 4? It doesn't, so I just need the positive one. So I'm going to use a calculator and estimate what the square root of 5 over 4 actually is. So I'll take 5, take the square root, divide by 4, 0.559 or 0.56 if we round to the hundredths place. And that's time, so we're going to label that as seconds. Okay, and that's T, that's our answer. Now let's do a couple more. Mr. Bro bought the iPhone app Send Me to Space, of which the object is to throw the iPhone in the air as high as possible. This is a real application and it actually exists. Don't actually throw your phone in the air. If Mr. Bro took your brand new iPhone 6S, now I suppose you're already on 10, this is a little outdated, maybe your iPhone 8, and threw it with an initial velocity of 45 feet per second, initial height of 6 feet, the first question I'm going to ask you is how high did the phone get in the air? When did this happen? Now, if I'm throwing this in the air, you can imagine it's going to follow the arc of a parabola. That's what we're studying, so that would make sense. And what's that highest point called? Of course, it's the vertex. And I want to know how high the phone got in the air if I threw it with initial speed of 45 feet per second, which, by the way, is incredibly fast. You have a pretty good arm. So let's find out. How do I find out the vertex? Well, before I do anything, I have to find the axis of symmetry. So that x value or time value is going to be negative b over 2a. Well, in order to use that, I need a formula. Well, the initial speed, v, is going to be that 45, positive 45t. What's the initial height? 6 feet. It says on the problem, initial height of 6 feet. I'm plugging that in for the s in the equation, and this is going to stay negative 16t squared. Now I have my b and I have my a. So I have negative times 45 all over 2 times a, which is negative 16. So I get negative 45 over negative 32, which turns into a positive 45 over 32. So let's find out what that is in our calculator. 45 over 32 looks about 1.40625. So that's when it happens, and I should make this a t for time. It happens about 1.40 seconds, actually 41 if I round. So 1.41 seconds is when that iPhone is going to reach the top of the parabola. And I want to know how high it got, so I'd have to plug it into this equation. And so again, I'll save time. I'm going to do the calculations off the screen, but I'm going to write down what I'm going to type into the calculator. The calculator I'm going to type in, or the thing I'm going to type in the calculator actually, 1.41 squared times 16 plus 45 times that 1.41 plus that initial velocity of 6 feet, and we'll see how much that is. And you see, after everything is said and done, I end up getting about 37.64 feet in the air. That's a pretty good toss. That's about 4 stories in the air. So like I said, you really threw that iPhone up there. How long was the iPhone in the air? Well, this would require me to figure out when the iPhone hit the ground again. Now, if I'm thinking about that, okay, if I start at initial height of 6, it hits the ground when I find an x-intercept. So I need to set that equation from before, that negative 16t squared plus the 45t plus 6 equal to 0, and solve for t. And again, we could do that off screen. It would take a little while. You could use the quadratic formula, and that's how we can get it. And I'll do that quickly. After using the quadratic formula, I find out the time is about 2.94 seconds before that iPhone will hit the ground again. Let's say in another situation that you're bored and you're throwing a baseball up in the air, and maybe it's something else, but you're just tossing up in the air and then catching it. So let's say you're throwing with velocity of 5 feet per second from an initial height of 4 feet. How high did the ball get in the air? When did this happen? Same type of question. Let's write the equation of h of t, though. Let's find out how I figure out the height of any object, or any time t. I get negative 16 times t squared, because that's gravity, plus the initial velocity of 5 feet per second times time, plus initial height of 4 feet. So I want to know how high I got in the air. Again, we're finding what point? Top of the parabola. It is the vertex. And so use the x equals negative b over 2a, and then you have to plug that in. Okay, and of course it's not going to be x, so we should use t instead. I apologize. It should be t equals negative b over 2a. And then you plug in and you find what h of that vertex is. So you're going to have h of negative b over 2a. That's all the time we have in the video. We'll finish the rest of this exercise in class. I hope you have a great evening.